Good morning. Welcome to today's Explainer. For teaching rounds today, I've got a case that perfectly highlights our entire approach to abnormal liver chemistries. We're going to walk through a real admission to demonstrate exactly why the pattern of injury always dictates our differential and, why the phrase liver function test is actually a pretty massive clinical misnomer for most of what's on this panel. Let's get right into it.
Here is our roadmap for the presentation. 1. The patient and the problem. 2. Injury versus true function. 3. Patterns and the R value. 4. Assessing mild and severe elevations. And finally, 5. Locking in a diagnosis for our patient.
Section 1. The patient and the problem. We're consulting on a 54-year-old man. His past medical history is significant for type 2 diabetes, obesity, and hyperlipidemia. Now, he is entirely asymptomatic. Literally, these labs were only drawn for a routine life insurance policy. For the history that really matters here, he volunteers exactly 0 drinks per week, and we quantified that honestly. He takes absolutely no over-the-counter medications or herbal supplements, he has no occupational or travel exposures, and there's 0 history of tattoos or blood transfusions, no family history of liver disease either. On exam, he's obese with a BMI of 32, but there are absolutely no stigmata of chronic liver disease. I'm talking no hepatomegaly, no spider angiomata, no palmar erythema, and no asterixis.
Then we get to his screening panel. His alanine aminotransferase, or ALT, came back at 88. His aspartate aminotransferase, or AST, is 62. His alkaline phosphatase is 140, and his total bilirubin is completely normal at 0.9. So looking at these numbers, the immediate questions we have to answer on rounds are, is this primarily a hepatocellular or a cholestatic picture, and does the magnitude of this rise actually narrow our differential at all? But before we even try to categorize that, we have to correct a super common nomenclature error. You'll hear this panel called liver function tests, but that's actively misleading. AST, ALT, alkaline phosphatase, and bilirubin, they are merely markers of cellular damage or cholestasis. They don't measure the liver's actual synthetic capacity. Literally, only 2 routine tests on this entire panel genuinely measure true hepatic function, albumin and prothrombin time.
Which brings us to Section 2. Injury versus true function. Let's build the mechanism from the ground up so we know exactly what these enzymes mean when they show up in the serum.
Aminotransferases, AST and ALT, are intracellular enzymes. They belong inside the cell. They only leak out into the blood when hepatocyte membranes physically fail and undergo necrosis. Now, ALT is highly concentrated in the liver, meaning an elevation is highly specific to hepatic injury. AST, though, it's widely distributed. It lives in the heart, skeletal muscle, the kidneys, and even red blood cells. Because of this wide distribution, if you ever see an isolated AST rise where the ALT is perfectly normal, you absolutely need to order a creatine kinase test to rule out musculoskeletal injury or a myocardial infarction before you even think about starting an exhaustive liver workup. You don't want to go chasing a liver problem when the issue is actually in the muscle.
Next up is alkaline phosphatase. This enzyme physically lives on the canalicular membrane. That's the bile-facing surface of the hepatocyte. It typically rises in response to biliary obstruction, intrahepatic cholestasis, or infiltration. But here's the catch. It's also produced in bone, the intestines, the kidneys, and the placenta. So an isolated rise in alk phos isn't automatically hepatic. To prove it's actually coming from the liver, you have to confirm it with a GGT, a 5' nucleotidase, or isoenzyme fractionation.
And this brings us to bilirubin, which brilliantly illustrates why tracking the actual molecule through its life cycle matters. When red blood cells turn over and heme breaks down, it produces unconjugated or indirect bilirubin. This stuff is completely water insoluble. So an isolated elevation points to hemolysis or a conjugation defect like Gilbert syndrome, and because it is water insoluble, you will never, ever see it in the urine. But once the hepatocyte takes it up and processes it, it becomes conjugated or direct bilirubin. This fraction is water soluble. When direct bilirubin is elevated, it's pointing us strictly toward cholestasis or an excretion disorder. And crucially, because it's water-soluble, it actively spills into the urine, which is something you can easily spot.
Returning to our only 2 true function tests, we have to look at their half-lives. Albumin has a half-life of about 15 to 18 days, which makes it our go-to marker for chronic synthetic failure. Prothrombin time, or PT/INR, on the other hand, relies on clotting factors with half-lives measured in mere hours. That makes it our early warning system for acute liver failure. So if you see a normal albumin but a prolonged PT, it tells you the liver hasn't been failing for very long.
Moving on to Section 3, Patterns and the R value.
We must establish the shape of the data before we react to its height.
We use the R-value formula to turn a visual pattern into a hard objective number. You take the ALT divided by its upper limit of normal, and then you divide that entire value by the alkaline phosphatase divided by its upper limit of normal. If that R value comes out above 5, you have a hepatocellular injury. If it's below 2, it's cholestatic. And if it sits right in between 2 and 5, you're looking at a mixed picture.
Mapping this out across our main clinical categories, we clearly see distinct phenotypes. Hepatocellular patterns predictably spike the aminotransferases. In things like viral hepatitis or metabolic disease, the ALT is usually higher. But if you see an AST that is higher than the ALT in a 2-to-1 ratio, that strongly suggests alcohol-associated liver disease. Conversely, cholestatic patterns prominently spike the alkaline phosphatase and the direct bilirubin. And finally, severe ischemic hits, they will massively spike absolutely everything, pushing the aminotransferases through the roof.
So, applying this math back to our asymptomatic 54-year-old man with an ALT of 88 and an alk-phos of 140, his R value lands well above 5. We are definitively dealing with a hepatocellular pattern.
Section 4. Assessing mild and severe elevations. Before returning to our patient, let's review how we algorithmically process these hepatocellular patterns on the wards. For chronic mild to moderate elevations, which we define as an ALT or AST under 15 times the upper limit of normal, we have to methodically work through the hepatocellular differential in order. We don't just guess, we work the list. We check viral serologies for hepatitis B and C, we assess metabolic factors like BMI, hemoglobin A1C, and we always get a liver ultrasound. We look for hemochromatosis with iron studies. If the patient were younger, we check ceruloplasmin for Wilson disease, plus alpha-1 antitrypsin deficiency. And we absolutely can't forget to screen for autoimmune hepatitis using IgG and autoantibodies, or investigate easily missed endocrine and autoimmune issues like thyroid dysfunction and celiac disease. All of these can quietly drive up those numbers.
Now, if the elevation is acute and severe, meaning an ALT or AST over 1,000 units per liter, that differential list gets incredibly short and highly critical. We immediately look for ischemia from shock, hypotension, or severe heart failure. We look for drugs and toxins, acetaminophen being number 1 by a mile, alongside meds like amiodarone or checkpoint inhibitors. And we check for acute viral infections, hepatitis A through E. Crucially, massive elevations above 5,000 are almost exclusively ischemic or drug-induced. Alcohol alone simply does not cause elevations this extreme. And as a quick clinical pearl, an ALT to LDH ratio under 1.5 heavily favors ischemic hepatitis.
If our R value had pointed to a cholestatic pattern, everything would pivot on a strict 3-step algorithm. You identify the raised alk-phos and bilirubin, and immediately order a right upper quadrant ultrasound. That ultrasound is the single major branch point of the entire algorithm because it answers one crucial question. Are the biliary ducts dilated? Dilated ducts mean mechanical obstruction, like a stone, stricture, or tumor, which needs an ERCP or MRCP. Non-dilated ducts mean the problem is inside the hepatocyte or the microscopic ducts, which points us toward medications, primary biliary cholangitis, or sepsis.
And if we were seeing an infiltrative pattern, meaning a significantly raised alk-phos with near-normal bilirubin and aminotransferases, we'd first confirm it's actually hepatic with a GGT. Then we'd move to ultrasound or CT imaging to look for malignancies or abscesses. If imaging is negative, we'd consider an MRCP or maybe serum protein electrophoresis to rule out amyloidosis, and we'd very likely end up needing a liver biopsy to definitively diagnose granulomatous diseases like sarcoidosis or TB.
Section 5. Diagnosing our patient. Let's bring all this clinical reasoning right back to the bedside to lock in our assessment and plan.
Let's apply all of this to our guy. His aminotransferases are well under 15 times normal, and his R value confirms a chronic mild hepatocellular pattern. Notably, his ALT is higher than his AST, which strongly argues against alcohol-associated liver disease, corroborating his history. His albumin and prothrombin time are completely normal, meaning his synthetic function is fully intact. We sent off the exhaustive workup, viral hepatitis serologies, iron studies, ceruloplasmin, autoimmune markers, and celiac serology, and they were all completely negative. However, his ultrasound did show increased hepatic echogenicity, suggesting fat infiltration. So given his BMI of 32, his type 2 diabetes, hyperlipidemia, and this mild ALT predominant pattern with a negative serological workup, our definitive diagnosis is metabolic dysfunction-associated steatotic liver disease, or MASLD. We ruled out the rest, and the metabolic phenotype fits perfectly.
For ward management and our ongoing plan, we have to recognize a crucial clinical reality. While fat in the liver is incredibly common, it's the fibrosis that actually determines the patient's clinical outcome and mortality risk. So we're prioritizing non-invasive fibrosis assessment with a FIB-4 score and elastography ahead of a biopsy, since these scores perform exceptionally well at excluding advanced fibrosis. Our therapeutic plan for him requires targeting greater than 10% weight loss, rigorous exercise, and strict diabetes and lipid control. We're also going to evaluate him for GLP-1 receptor agonists and novel therapeutics like resmetirom. Finally, we'll repeat his liver panel in 3 to 6 months to track his trajectory and ensure our interventions are working.
To wrap up this explainer, I want to leave you with 3 high-yield clinical pitfalls to avoid. First, remember that a perfectly normal early ultrasound doesn't fully exclude early biliary obstruction. If your clinical suspicion remains high, you have to repeat it or image further. Second, a completely normal liver panel does not exclude advanced steatohepatitis on biopsy. And third, never forget that only albumin and prothrombin time actually measure hepatic synthetic function.
The golden rule on the wards is this. Always shape the data and read the pattern before you react to the magnitude. But I'll leave you with this final, provocative thought. As metabolic disease completely reshapes global health, how many silent cases of advanced cirrhosis are currently hiding in plain sight behind a quote-unquote mildly abnormal routine life insurance lab draw? Thanks for joining me on Rounds today.